So I had a really weird moment this morning. I was just typing an email, a standard update to a colleague, and I paused.
Mm.
And it wasn't because I didn't know what to say. It
Yeah.
was because this gray ghost text appeared on the screen, and it just finished the sentence for me.
Oh, yeah.
And I just hit tab, sent it, and then it hit me.
Yeah.
That wasn't exactly what I was going to write. It was just, I don't know, close enough.
The path of least resistance.
Right. And it got me thinking, we're all so used to the red squiggle, the thing that tells us we're wrong.
That's been around forever.
Exactly. But it feels like we've quietly slipped into this new phase where the computer isn't just correcting us. It's predicting us. It's telling us what we should say.
It's a fundamental shift, and to really understand how we got here, to this point where machines are finishing our sentences, we have to look at the whole history of automated writing assistants.
Which sounds very academic, but it's really just the history of the spell checker, isn't it?
Well, it starts there, sure. But as Robert Dale explains in the work we're looking at today, it evolves into something much, much more complex. It's really the history of computers trying to understand human intent.
And failing. And trying again.
And failing and trying again.
So today we're doing a deep dive into the mechanics of that red squiggle. We're going to look at how computers learn to read our typos, why they basically gave up on learning grammar rules, and why that ghost text might be a much bigger deal than we think.
And I think we should start with the fact that for a very long time, the computer had absolutely no idea what you were trying to say.
Okay, so this is the 1960s, the birth of spell check. I think most people assume the computer is actually reading the word, but the first method was way simpler than that.
Much simpler. It was basically a bouncer with a guest list.
Ah, I like that.
It's the list lookup method. The computer has a dictionary, right? A literal list of character strings it accepts as valid. It looks at your word. Is it on the list?
You're good.
You're good. Is it not on the list? Error.
Yeah.
Red squiggle.
Okay, but that works for a standard sentence. What if I'm writing a sci-fi novel? Or, I don't know, I have a friend with a unique name.
And that's the flaw.
Yeah.
Exactly. If you type a name like sawars or some technical term that isn't in its dictionary, it flags it. The computer doesn't know it's a name. It just knows it's not on the list.
And I'm guessing the opposite is true, too. This is the part that always drives me crazy. What if I type a word that is on the list, but it's just the wrong word?
You've just hit on the single biggest headache in the history of spell checking. Dale calls these real word errors.
Give me an example.
Okay, the classic is typing form, F-O-R-M, when you meant from, F-R-O-M.
Right.
Both are valid English words. Both are on that guest list. So the spell checker looks at your sentence, sees the word form, checks the list and says, yep, come on in. It doesn't say a thing.
Even though my sentence is, I received the email from you.
Exactly. To a list lookup system, that sentence is perfect. And this is not a small edge case. Some estimates suggest that these real word errors could be up to 40% of all spelling mistakes.
40%? That seems really high.
It does, but think about it. There versus there, it's versus it's. These are the hardest ones to catch because the word itself is perfectly valid.
So if the list method is that flawed, how do they start actually fixing things? Once the computer flags a word as wrong, how does it know what I meant to type?
So this brings us to a concept called edit distance. It goes back to a researcher, Damerau, in 1964, and he analyzed a huge amount of typos and found something kind of reassuring about human clumsiness.
Which is what?
We're consistent in our mistakes. He found that 80% of all spelling errors are just one single operation away from the correct word.
One operation. You mean like one keystroke?
Basically, yeah. It's either an insertion, you added a letter, a deletion, you missed one, a substitution, you hit A instead of S, or a transposition, swapping two letters like the I and E in there.
So the computer takes my typo, my garbled word, and it just calculates, okay, what actual words are just one step away from this?
Exactly. You type te, the computer looks for words that are one change away. The is a match. T might be a match. It just generates a list of candidates based on that simple math.
But Dale makes a pretty important distinction here about why we make these mistakes. He talks about errors of execution versus errors of intention.
Yeah, and it's a really useful distinction. An error of execution is just a slip. You know how to spell accommodate, but your finger slipped and you missed a C. Fat fingers.
Guilty.
We all are. But an error of intention is different. That's when the writer, they genuinely don't know the spelling. They're typing exactly what they intended to type, but their knowledge is wrong.
Like thinking definitely has an A in it somewhere.
Right. And strictly speaking, edit distance is fantastic for fat fingers. It's not so great for someone who is just phonetically sounding out a word that looks nothing like the correct spelling.
Okay, so we've got lists and we got this one-step away math.
Mhm.
But that still doesn't solve the form versus from problem. Because form isn't a typo. It's just the wrong word.
And to solve that, you have to stop looking at the word in isolation. You have to look at its neighbors. You need contextual checking.
So this is where we get into grammar, right?
Sort of. This is where the history of this tech gets a bit messy. The researchers realized they needed to understand the relationship between words. So take the sentence. The catted on the mat.
The catted on the mat. Okay, it is a real word, but it makes zero sense there.
Right. A human sees that and immediately knows that's a pronoun where a verb should be.
But a computer in the 1980s has no idea what a pronoun is.
Not really, no. So the engineers tried to teach it. This was the era of what they call rule-based approaches. They tried to hand-code all the rules of English grammar into the system.
That sounds like a complete nightmare. I mean, English is barely a language. It's
Yeah.
like 3 languages in a trench coat. It breaks its own rules all the time.
It was a massive undertaking, and they used things like malrules.
Mal rules.
Yeah, it's short for malformation rules. Basically, error anticipation. Programmers would explicitly write rules for the most common mistakes people make.
So they were playing defense, trying to predict every single way a human could mess up a sentence.
Pretty much. And they also use something called constraint relaxation, which is fascinating. Let's say you type, the dogs runs.
Okay, plural dogs, singular runs. Got it.
So the computer tries to map that sentence against its strict grammar rules, and it fails. It hits a wall. So the program is designed to then say, okay, let me temporarily ignore or relax the rule that says subjects and verbs have to match in number.
It breaks its own rules to see if the puzzle pieces suddenly fit.
Exactly. And if the sentence parses correctly after relaxing that one rule, the computer goes, aha, that must have been the error, a number agreement error.
But that still feels like a losing battle. You're basically playing whack-a-mole with the entire English language. Humans are just. We're infinitely creative at making mistakes.
You are absolutely right. You can't code a rule for every single exception.
Yeah.
And that is the key pivot point in Dale's research. The industry realized it couldn't teach computers to understand grammar.
So what do they do?
They had to teach them to count. To count.
Probability. Instead of asking, is this rule broken? They started asking, how likely is it that these 3 words appear together? This is the big shift to statistical models and trigrams.
Trigrams.
3-word chunks.
Right. Take the sentence, the cat sat on the mat. Grammatically, that sentence is fine. A rule-based checker might let it pass.
Set is a verb. Looks okay to me.
But a statistical model looks at its massive database, millions of sentences, and asks, how many times have we seen cat, set, and on appear together in that order?
And the answer is probably close to never.
Correct. The probability is near zero. But the probability for cat sat on the mat is extremely high. So the computer suggests sat. It doesn't know why set is wrong. It just knows it's statistically a very, very weird thing to say.
It's just playing the odds.
That's all it is. And this was completely revolutionized by the web. Suddenly, researchers didn't need to handwrite rules anymore. They had the entire internet as their data set. They could just mine all that text to see what correct English usually looks like.
And this was huge for ESL learners, right? English is a second language.
Oh, massive. Dale points out that ESL learners often struggle with very specific things, like determiners and prepositions.
The determiners being the and a.
Right. And if your native language doesn't use articles, knowing when to put the in a sentence is incredibly difficult. And prepositions. In the car, but on the bus? There's no logic to it. It's idiomatic.
You can't write a rule for that. You just have to learn it by exposure.
Exactly. So the computer uses sequence mining. It compares what a student wrote against millions of correct sentences to see if it sounds like what a native speaker would say. It's no longer checking, is this illegal? It's checking, is this normal?
Okay, I want to pivot here for a second, because we've been talking about the mechanics of how it all works. But Dale brings up a much deeper problem. It's not just that the computer is bad at fixing errors sometimes. It's that it's interrupting us at completely the wrong time.
Yes. This is the clash between the stage model and reality.
Which means the computer assumes writing is this neat, linear process.
Right. The software assumes you write, and then you edit. So it pops up that red squiggle the absolute second you make a typo.
Which just kills your creative flow.
Completely. But humans don't work like that. There's this cognitive process theory that Dale cites, and it argues that writing is recursive. We are planning, we're translating ideas into words, and we're reviewing all at the same time in a big, messy loop.
So I'm in the middle of a thought, just trying to get the idea out of my head, and the software is basically tapping me on the shoulder, forcing me to be a copy editor.
It's friction. The tool is trying to polish the doorknob before you've even built the house. Dale argues that a true writer's workbench shouldn't just be a post editor. It should help with something he calls NLG, natural language generation.
And this sounds a lot closer to where we are now with AI. He talks about tools that help with content selection.
Yes. Imagine a tool where you don't start with sentences. You just start by dumping bullet points, loose ideas. Complain to airline, luggage lost, want refund. And the system helps you structure that argument before a single sentence is even formed.
That's symbiotic text generation.
It is, and that leads to a line generation, rewriting a sentence to match a specific style, not just fixing an error, but changing the whole tone, make this more professional, make this sound friendlier.
Which brings us, inevitably, to the modern era. The source material has a postscript from 2019, and I mean, the speed of change here is just dizzying.
It really is. The entire field shifted from all these specific rules, this is a spelling rule, this is a grammar rule, to deep learning.
Which connects back to what you said earlier about translation.
Yes, this is the key insight of the modern era. In machine translation, you train a model to turn French into English. Well, in modern writing assistants, they train neural networks to turn bad English into good English.
So they don't teach the computer why a comma is in the wrong place. They just show it a million examples of bad sentences paired with good sentences and say, you figure out the pattern.
Precisely. They treat error correction as a translation task. And because of that, the tools stopped being these clunky rule-following robots and started becoming these really nuanced style coaches.
And we saw Grammarly just explode around this time.
Founded in 2009, by 2017, they had almost 7 million daily users. Microsoft had to scramble to respond. They upgraded Office in 2016. The red squiggle became a billion-dollar industry.
But then Google came out with Smart Compose. And this is where we loop right back to my ghost text story from this morning, because Smart Compose isn't correcting anymore. It's predicting.
This is the fundamental shift from "is this wrong" to "here's what you're probably going to say next."
And I use it all the time. I'll start typing, hope you are, and it just fills in doing well. I tab and I keep going. It's so convenient.
It is convenient, but Dale shares this really telling anecdote and analogy about a pizza ordering system that I think just perfectly captures the danger.
Wait, pizza?
It's the perfect analogy. He worked on an early voice ordering system for a pizza chain. The system would listen to the customer and then try to confirm the order. But, it would often mishear them.
And I assume the customers got mad.
You would think so. But what he found was that if correcting the robot was too difficult, if you had to repeat yourself 3 times just to get extra cheese, people would just give up.
They just eat the wrong pieces.
They would literally accept a pepperoni pizza they didn't order just to end the painful interaction.
That's bleak.
It is. And the fear is, are we doing the exact same thing with our writing?
So Smart Compose suggests an ending to my sentence. It's not exactly what I wanted to say. It's a little blander, maybe a little more corporate, but it's grammatically perfect.
Yeah.
And all I have to do is hit the tab key.
So you hit tab, you accept the pepperoni pizza because it's easier than actually crafting your own unique thought.
We all start sounding like the average of the text the model was trained on.
We flatten out. We lose our unique voice, our edge.
And this brings us right to the ethical moment of this whole thing.
Yeah.
We're moving toward what Dale calls self-writing documents.
He references this kind of inversion of the George Orwell, 1984 concept. He says, in such a world, Big Brother is not watching you. He's relieving you of the need to be watched.
That's terrifyingly plausible. Unpack that for me.
Well, we usually think of censorship as someone coming along and deleting what you wrote. But if the machine auto-completes your thoughts to be safe, standard, and perfectly grammatical before you even finish typing,
You don't need a censor.
you don't. The tool itself prevents you from ever stepping out of line. It guides you into the safe, average lane before you can even think about making a mistake.
It relieves you of the burden of choice.
And that right there is the danger. These tools are becoming invisible collaborators in our own writing process.
So I guess the next time you see that red squiggle or you see that gray ghost text offering to finish your sentence for you, maybe just take a beat.
Yeah, and ask yourself, is this really what I wanted to say? Or is this just what the machine thinks I should say?
Because if we're not careful, we might just end up ordering the pepperoni pizza of literature for the rest of our
Yeah,
lives.
and nobody wants that.
Thanks for diving deep with us today. Keep writing, and maybe ignore the suggestion every once in a while. We'll catch you next time.